Hi viewers, this is Dr. Janna and you are watching me with the video machine learning and you are welcome to this world of machine learning. As you know that is machine learning is a branch of artificial intelligence and it is based on the idea that system can learn from data. It can identify a pattern and make decision with minimal human interventions. Okay, so we understand that we can go for some data analysis that automates the analytical model building. That is the main purpose of this machine learning. So then what it involves, what is the constitution of this? So this machine learning involves algorithms, mathematical models employed to make machines learn and prepare them to adapt in everyday advancement. For example, say time series forecasting, it is very much in use in trading and financial systems. Here, based on the historical data patterns, the machine can predict the outcomes for the future months of years. And this is an application of this machine learning. So in this way, we can have a number of things here. So we move to the second slide where we can see what are the, yeah, just I'll give you the, bear with me 1 minute. Here, these are some of the applications of this machine learning where in a day-to-day life we use. So we can go for the self-driving Google car. It is already implemented, I think you will be knowing. Then online recommendations offer such as those who are purchasing from Amazon or Netflix, knowing what customers are saying about you on the Twitter, fraud detections, robotics, language processing, vision processing, forecasting in stock market trends, weather forecasting, games, everywhere we are using. So these are some of the important things I told you, but there are a lot of applications day to day life. Clear? So in this way, now we go to the different type of learnings. So the important, there are around 4 type of learnings are there. The first one is the supervised learning. In this supervised learning, yeah, we can give me 1 minute. You can see in the supervised type of learning, these algorithms are trained using labeled examples. What is the meaning of these labeled examples? Such as an input where the desired output is known. Say for example, I show this one and the output is this one. So for this input, this is the output. So that means it is a labeled one, right? And for example, a piece of equipment could have a data point labeled either, say suppose some equipments are there, the equipment are running or not running, that we can represent it either labeled by F or R. F stand for the failed, R stand for the running or runs. And the learning algorithm receives a set of input along with the corresponding correct outputs, and the algorithm learn by comparing its actual output with correct outputs to find the errors. That means what is the actual output that we are getting and what is the desired output, what is the correct output, both the things we compare and the difference is the error. And if then modify the model accordingly. So this is the thing in case of in our supervised learning. Then once we go to the next type of thing, that is the and another thing also, you can take some example of all the things. So you see through these methods we are using a number of things like, here we can, you can see through methods like classification, regression, predictions and gradient boosting. Supervised learning use patterns to predict the values of this level on additional unlabeled data. So suppose for the labeled data we know for this is the output, for unlabeled data also it will be able to predict. And supervised learning is commonly used in applications where historical data predicts likely the future events. For example, it can anticipate with credit card transactions are likely to be fraudulent or which insurance customer is likely to be to file a claim. So all the things we can easily and comfortably we can predict with this thing, right? So these are the things. Then we are going for the next one, that is the unsupervised learning. In this unsupervised type of learning, you know, so there is label data is not available. You get it now? So you cannot get any label data. Here you see I'm just focusing here. It is used against data that has no historical labels. You get it now? That means we do not know the output before that one. The system is not told the right answers and the algorithm just it must figure out what is being shown, and the goal is to explore the data and find some structures within, right? So unsupervised learning works well on transactional data. For example, it can identify segments of customers with similar attributes who can then be treated similarly in marketing campaigns, or it can also find main attributes that separate customer segments from each other. So popular techniques including the self-organizing maps SOP, SOM, and nearest neighbor mapping, k-mean clustering, and singular value decompositions, all the things we are using there. And these algorithms are also used to segment text topics, recommend items, and identify data outliners. Right. So these are the things, and we are having another two. So we will be having some semi-supervised learning. This semi-supervised learning, it is similar to that of the supervised learning. Okay. So then what is the difference we see? Let us see. Yeah, you can see. In the semi-supervised learning, it is used for same applications as supervised learning, but it used both labeled and unlabeled data for training, right? For training purpose, we can use both labeled data as well as the unlabeled data. Now you can understand what is labeled and what is unlabeled. And typically a small amount of labeled data with a large amount of unlabeled data, because unlabeled data is less expensive and takes less effort to acquire. You got it now? That is the main reason. So that means easily we can acquire this unlabeled data, but labeled data it is little expensive. And this type of learning can be used with methods such as classifications, regressions, and predictions. And semi-supervised learning is useful when the cost associated with the labeling is too high to allow for a fully labeled training process. And early examples of this includes identifying person's face on a webcam. So these are the things it is possible, right? Then we are moving to that we are calling about the reinforcement learning. Okay. In this reinforcement of learning, what happens? Let us see. So here. Yeah, so why it is behaving like this, I do not know. The reinforcement learning, it is often used for robotics, gaming, and navigations. For this purpose, we are using this reinforcement learning. So with reinforcement learning, the algorithm discovers through trial and error which actions yield the greatest rewards. And this type of learning has three primary components: the agent, that is the learner or the decision maker; the environment, everything the agent interacts with; and actions, what the agent can do. These are the three things involved in this reinforcement learning, right? So the objective is for the agent to choose actions that maximize the expected reward over a given amount of time. This is the objective of the agent. And the agent will reach the goal much faster. You know, when we are going for this game playing, so this type of algorithm is most suitable. And the goal much faster by following a good policy. So the goal in reinforcement learning is to learn the best policy, right? So these are the some of things we are coming across these things. Then before we moving to the machine learning, let us have a comparison among the three. That is your what is this machine learning and no. So yeah, just you give me some time. Yeah. Yeah, you can clearly see here. We are having three things. One is the data mining, one is the machine learning, another is the deep learning. So once you understand what is the difference here, it will be easy for us to proceed. Okay. So what happens? Okay, machine learning, deep learning, they are related. What is this data mining? Data mining can be considered a superset of many different methods to extract insights from the data. You get it now? Data is because the entire world is flooded with data, but information is more important. That how we can get the insight from this data, that is taken care in the data mining. It might involve traditional statistical method and machine learning also. And data mining applies methods from many different areas to identify previously unknown patterns from the data. And this can include statistical algorithm, machine learning algorithm, text analytics, time series analysis, and other areas of this analytics. And data mining also includes the study and practice of data storage and data manipulations. Everything we can do with these things. Then what is this machine learning? The main difference with machine learning is that just like the statistical models, the goal is to understand the structure of the data and feed theoretical distributions to the data that are well understood. So with the statistical models, there is a theory behind the model that is mathematically proven. But this requires that data meets certain strong assumptions too, and the machine learning has developed based on the ability to use computers to probe the data for structures. And even if we do not have a theory or what that structure looks like, and the test for a machine learning model is a validation error on new data, not a theoretical test that provides null hypothesis, because machine learners often uses an iterative approach to learn from data this learning can be easily automated, passes and run through the data until a robust pattern is found. Then what is this deep learning? Deep learning combines advances in computer power and special type of neural networks. So you are using some algorithm like from the neural network base, that is the convolutional neural network, like that you might be heard about that one. So learn complicated patterns in the large amount of the data. And these deep learning techniques are currently state of the art identifying objects in images and words and sounds, right? The researchers are now looking to apply these successes in pattern recognitions to more complex tasks such as automatic language translations, medical diagnosis, so, and numerous other important social. And you will be having some apps now. So you talk in German language, Dutch language, you in French language, you are in Japanese language, automatically it is converted to your languages. That is the application of all these things, right? So these are the some of the important the difference between all these things. And once you get all the things, now we are going to what are the algorithms we'll be using here, right? Here let us see what are the algorithms we are having. We are having a number of algorithms we can apply to the machine learning. Some of the important algorithm I am putting it here, we can have it here. Yeah, you can have it here. So we have the neural networks based algorithms are there, decision trees are there, random forests are there, association and sequence discovery is there, gradient boosting and bagging is also there, support vector machine SVM is there, nearest neighbor mapping is also there, and k-mean clustering is there, and self-organizing maps are there. So these are the number of algorithms. We will be working with one or two out of this, and you see we will be working on this CNN during the network, and the decision tree also using. I'll show you some sample project how to work on that one. So these are the things we'll be working, some of these, and I will be giving some idea about how to use this nearest neighbor and how to use this support vector and k-mean clustering in our next video, right? So now then now let us come to conclusion what this machine learning we learned and what we are going to do it here, right? So here we can see the question is that already traditional programming are there, so we can also go for the prediction and everything with that one. When those are existing, why we go for this machine learning? In machine learning we solve a real world problem, you got it now, and here we build a model which can predict. The main thing is that we build a model, and when you giving, so with this model you take some data, and with that we train the model. Once the model is trained, for any new things it can predict, right? So machine learning, it is also subset is mistake is there of artificial intelligence. For example, we can scan an image and tell it is a cat or dog, that we can do. And if you try to solve it using traditional languages, a lot of code involves, and if you take an image with different angles also, the program will be unable to predict that one also. You get it now? So these are some of the demerits of this traditional programming. Okay, then it becomes complex and sometimes impossible also. Suppose we modify the category and add horse. So initially it was a dog and cat, I added horse. So we need to modify the rows and rewrite the enter coding and all things. The machine learning gives a solution for this type of programming. And we built a model and engine and give a lot of data, say around 10,000 pictures for each category, and our model will find and learn pattern. If you give a new picture, then the machine tell about certain accuracy. Okay, then it will be able to predict that one. So this is all about the theory. I think a lot of theory, it gives a lot of confusion. So the next video will be mainly focusing some 2 or 3 case study. The first of all, we are will be using this decision tree. Will be using that one. The second one will be using the convolution neural, that is the neural network based. So thank you for watching this video, and if you like these things, please share with your friends, and also don't forget to subscribe this video also. And if you have any comments or anything, you are welcome. Take care of all. Thank you. Goodbye.